VLSos here. This is a video lesson on derivative notation. Let's remind ourselves what the derivative is. The derivative is a slope calculation. And it started with considering what we knew about slope, which is the slope of the line that connects 2 points, or slope of a secant line. And that slope calculation came from algebra. We thought of it as a rise over a run, or delta y over delta x, where delta y was the change in y coordinates, the rise, and the run was the change in x coordinates, delta x. Then we considered if we took that slope calculation, the slope of the line that connected 2 points, and we moved those 2 points together, if we shrunk the run, the delta x, to 0, the points would come together. The line would no longer be a secant line. It would be a tangent line that intersects the function or grazes the function at one point. In order to do that symbolically, we introduced the limit as delta x shrank to 0. And the slope of the secant line became the slope of the tangent line, and we learned to call that the derivative. The derivative is a slope calculation where the run, or delta x, goes to 0. We have notation for the derivative. If we were given a function, f of x, then we have a quick, simple notation. It's called prime notation to mean the derivative. In this case, we put a tick mark above or superscripted with the f, and we read it as f prime of x, the derivative of f. We can take the derivative again, and we can add tick marks in the prime notation. In this case, f double prime of x is the second derivative of f. We could keep going with this. If we put an n, then we mean the nth derivative of f. But we have different notation for the derivative. Prime notation is quick and simple, but there's a notation that is more useful for more complicated problems that require more organization of the symbols in order to help the process. And that notation takes advantage, or is reminiscent, the original delta y over delta x. That notation is using a d instead of the delta symbol. dy over dx stands for the derivative. And when we change the deltas into a d, it's implying that this slope calculation included the limit of the delta x going to 0, and therefore is a derivative. So this limit and the traditional slope calculation gets wrapped up into this symbol. Let's use this symbol for the derivative. For example, we could be given an equation y is equal to 3x plus 2. And if we wanted to find the derivative of y, we could symbolize it as dy over dx, the derivative of y with respect to x. And we can take that derivative using the power rule. In this case, the derivative would be 3. It's another example. This time I'm going to have an expression, 4x squared minus 7x. What if I wanted to take the derivative of this? Well, I would write that instruction down this way, d over dx. In other words, the derivative of 4x squared minus 7x. And I could answer that question with the power rule, bring the 2 out in front and multiply. And the derivative of negative 7x is negative 7. Notice the difference in the use of the symbol. Here I have a y, and here I don't. In the symbol for the derivative, what belongs in the numerator after this first d is what you're going to take the derivative of. So when we say dy over dx, we mean take the derivative of y. What's y? Well, it's the equation that we gave before it. In this use of the symbol, there is nothing that's next to the d, because what we're taking the derivative of appears right after the symbol for the derivative. It's almost as if this belongs in the numerator of the symbol which looks like a fraction. It is a fraction. This notation will be an advantage when we consider it as a fraction for problems in which we can separate the denominator and the numerator and make use of it in more complicated problems in the future. One more example. If we're given a function like 2 times sine x, we don't have to use prime notation with function notation. We can ask, what is the derivative of f with respects to x? df over dx. And what I'm taking the derivative of is the f function. The f function is 2 sine x. In this case, the derivative is 2 cosine x. And if we wanted to take the second derivative, then the notation would include a 2 above the d, the f that we're still taking the second derivative of, and then the dx also has a 2 above the x. Notice that the 2 is for the second derivative, and we needed to use it in the numerator and denominator of this notation. But the 2 goes above the d in the numerator, and the 2 goes above the x in the denominator. There's a difference. Why? Because remember, f is what we're taking the derivative of. It's not a part of the notation for the derivative of f. The notation for the derivative is d squared over dx squared. And then the f is there to give us an understanding of what we're going to work on to take the second derivative. In this case, the second derivative of 2 cosine x is negative 2 sine x.